Hi friends, this is Nagmohan. Today topic convex lens. పబ్లిక్ ఎగ్జామినేషన్లో కాన్వెక్స్ లెన్స్కి సంబంధించి 3 టైప్స్ ఆఫ్ క్వశ్చన్స్ అడగడం జరుగుతుంది. మరి వాటికి సంబంధించిన క్వశ్చన్స్, ఫార్ములాసు, గ్రాఫ్స్ మనం బోర్డు పైన రాయడం జరిగింది. వాటిని ఒకసారి అబ్జర్వ్ చేద్దామా. మరి పబ్లిక్ ఎగ్జామినేషన్లో మనకు ఏ విధంగా క్వశ్చన్స్ అడగడం జరుగుతుందంటే, ఫస్ట్ వన్ వచ్చేసి డిటర్మైన్ ది ఫోకల్ లెంత్ ఆఫ్ ది గివెన్ కాన్వెక్స్ లెన్స్ బై యూవీ మెథడ్ అండ్ వెరిఫై ది రిజల్ట్ ఫ్రమ్ యూవీ గ్రాఫ్. సెకండ్ క్వశ్చన్ వచ్చేసి డిటర్మైన్ ది ఫోకల్ లెంత్ ఆఫ్ ది గివెన్ కాన్వెక్స్ లెన్స్ బై యూవీ మెథడ్ అండ్ వెరిఫై ది వాల్యూ ఫ్రమ్ 1/u - 1/v గ్రాఫ్. మరి థర్డ్ క్వశ్చన్ ఏ విధంగా అడుగుతారంటే, ఫైండ్ ద ఫోకల్ లెంత్ ఆఫ్ ది గివెన్ కాన్వెక్స్ లెన్స్ బై కాంజుగేటివ్ ఫోకై మెథడ్ అండ్ వెరిఫై ది రిజల్ట్ విత్ ది వాల్యూ obtained ఫ్రమ్ యూవీ గ్రాఫ్. ఈ విధంగా మనకు 3 క్వశ్చన్స్ అడగడం జరుగుతుంది. మరి వీటికి సంబంధించిన ఫార్ములాస్ అబ్జర్వ్ చేసినట్లయితే, డిస్టెన్స్ ఆబ్జెక్ట్ మెథడ్లో మనకు ఫోకల్ లెంత్ ఏ విధంగా వస్తుందంటే 1/f = 1/u + 1/v. మరి u అనేటువంటిది ఇన్ఫినిట్గా ఉంటుంది కాబట్టి దట్ ఇంప్లైస్ f = v సెంటీమీటర్స్ ఫోకల్ లెంత్ వస్తుంది. మరి యూవీ మెథడ్లో ఫోకల్ లెంత్ ఏమంటే f = uv/u + v సెంటీమీటర్ అవుతుంది. మరి యూవీ గ్రాఫ్ మెథడ్ నుండి మనకు ఫోకల్ లెంత్ ఏమవుతుందంటే స్మాల్ f = oa + ob/4 సెంటీమీటర్ అవుతుంది. మరి 1/u 1/v గ్రాఫ్ మెథడ్ నుంచి ఫోకల్ లెంత్ ఏ విధంగా వస్తుందంటే స్మాల్ f = 2/oa + ob సెంటీమీటర్ అవుతుంది. మరి కాంజుగేటివ్ ఫోకై మెథడ్ నుండి ఫోకల్ లెంత్ ఏ విధంగా వస్తుందంటే స్మాల్ f = l² - d²/4l సెంటీమీటర్ అవుతుంది. ఈ విధంగా మనకు కాన్వెక్స్ లెన్స్కి సంబంధించిన క్వశ్చన్స్, ఫార్ములాస్ అడుగుతారు. మరి గ్రాఫ్ చూసినట్లయితే యూవీ గ్రాఫ్ వచ్చేసి ఈ విధంగాను, 1/u 1/v గ్రాఫ్ వచ్చేసి ఈ విధంగాను ఉండడం జరుగుతుంది. మరి మనం ఎక్స్పెరిమెంట్ చేసే ముందుగా వీటికి సంబంధించిన యానిమేషన్ వీడియో ఒకసారి చూద్దామా.
కాన్వెక్స్ లెన్స్ ఫోకల్ లెంగ్త్. ఎయిమ్ to determine the focal length of a thin convex lens by obtaining the image of a distant object. Materials required: thin convex lens, a lens holder, a semi-transparent screen fixed to a stand, meter scale. Procedure: take a thin convex lens. Place the convex lens vertically on a lens holder kept on a table. The lens should face a distant object outside the window, a tree or an electricity pole, or a distant building. Place a screen fixed on a stand on the other side of the lens. Move the screen back and forth to obtain a sharp, clear, and inverted image of the distant object. Measure the distance between the screen and the optical center of the convex lens using a measuring scale. Record the observation as the focal length of the lens. Repeat the experiment at least 3 times and record it in the observation table. Find the mean value of focal length. Result: the focal length of the given convex lens is 15 centimeters.
Aim of this lab activity is that, here I am writing the aim of this lab activity. Aim: observing the types of images and measuring the object distance and image distance. okay, from the lens. So in this lab activity, we are going to observe the types of images. That means we have to place a candle in front of the lens and we have to obtain its image on the screen, isn't it? So where the image is formed, how the image is formed, and type of image, that is whether it is real image or virtual image, can we obtain it on the screen or not, that we are going to see. And later we have to measure the object and image distance in each case, okay. So the material required in doing this lab activity is material required. We need a candle, a burning candle, a paper or a screen, convex lens of known focal length of 15 centimeters. Here I am taking. You can take whichever the focal length you want. But here in this lab activity, I am taking a convex lens of focal length 15 centimeters. And we need a V stand to place the convex lens and measuring tape or meter scale to measure the image and object distances. Okay. So whatever the material required in this lab activity, I am going to show you clearly. So this one is a burning candle we need, and this one is the convex lens. It is the double convex lens, okay. And here is the V stand on which I am going to place this convex lens while doing the lab activity. And here is the screen or a paper also we can take in order to obtain the image of the object, okay. And here is the wooden block on which I am going to place this candle, and here is the meter scale to measure the image and object distances. And here is the procedure. See the procedure. Take a V stand and place it on a long, nearly 2 meter long table at the middle. That means we have to place the V stand on a long table at the middle. See here, this is the long table, okay, on which I am going to place the V stand at the middle somewhere here. So this is the V stand, okay. This is the V stand placed on the long table at the middle. And now we have to place the convex lens of known focal length we have taken. Place the convex lens on the V stand. So in this V stand, I am going to place the convex lens I have taken. This is the convex lens, okay, double convex lens. So, and the convex lens has been placed on the V stand, okay. And next here, light a candle and ask your friend to take the candle far away from the lens along the principal axis. So I will ask a student to bring the candle along the principal axis far away from the lens like this. So he may hold somewhere far away from the lens at one place, okay. Now this side to the other side, so the candle is towards right, and to the left of the lens, this side, I will hold a screen and adjust the screen in such a way that to get the clear image on it. Adjust a screen which is on the other side of the lens until you get an image on it, okay. So from this side, I will bring the screen slowly towards the lens until I get the clear image on it. So in this case, object is almost at infinity, far away from the lens. At that time, I am going to obtain its image on the screen by moving the screen slowly towards the lens. So I will consider this as the case 1. You see here, case 1. In case 1, where the object is placed here, the object is placed to the right of the lens at infinity. That means far away from the lens this side. Somebody is holding that candle this side. Okay, far away from the lens. So we know that we have taken the convex lens of focal length, known focal length. The focal length of the lens is 15 centimeters, isn't it? So here object is far away from lens, far away from lens. It means that object is at infinity. Now I am bringing the screen slowly toward the lens. Yes, here I got the clear image here on the screen at this position. So when the object is at infinity, on one of the sides of the lens, that is to the right side of the lens, so its image has been formed here. A small diminished, that is a diminished image has been formed. Okay, so see here, image is formed at the focal point F. We know that in case of ray diagrams, we came to know that when the object is placed in front of the convex lens, it forms its image on the other side at the focal point. So here, image distance is 15 centimeters only. Let us measure. So here, check the type of the image. It is the inverted image, upside down and highly diminished. This is this side. Actually, the size of the candle is too big to compare to the size of the image. So image formed in this case is highly diminished. Small image I got on the screen, and it is real image. Why? Because it has been caught on the screen. All the real images will be caught on the screen. The images which are caught on the screen, which are obtained on the screen, are called real images. So it is a real image. And let us measure the image distance. You see here, from here to here, from screen to the lens. From screen to lens, the distance is 15 centimeters. That means image has been formed at the focal point only. Okay, so image distance equal to 15 centimeters. This is the case 1. So next what I will do here is, I will move the object slowly towards the lens, and I will try to obtain its image in each case. So this is about the case 1. And here is case 2. That means I will place the object at the distance of, see here, focal length of the lens is 15 centimeters only. So here I am placing the object. Let us measure its distance by using the meter scale. So I have placed the object at the distance of 70 centimeters. Okay. So object distance is equal to 70 centimeters. Now, what I have to do? I have to bring a screen from the left side slowly towards the lens until I get the clear image on it. See here. This is the screen. I am moving slowly towards the lens. Here I got the clear image on the screen. So let us measure its distance. Here it is 19 centimeters. Image distance is equal to 19 centimeters. Okay, so it is the inverted image we got and diminished real. Okay, inverted, diminished means small in size, real image, and the image distance is equal to 19 centimeters. That means from here to here. Next, case 3, I will move the candle a bit closer to the lens. Focal length is 15 centimeters. Now I am going to place the candle at this position. This is a burning candle. I have placed it on the wooden block, and let us measure the distance. Object distance is equal to 60 centimeters. That is, object has been placed at the distance of 60 centimeters from the lens. So here object distance is equal to 60 centimeters. Now I will bring the screen slowly towards the lens until I get the clear image on it. See how I am moving it? That's all. Here I got the clear image. Okay, so let us measure its distance. It is 20 centimeters. So from here to here, it is 20 centimeters. So image distance is equal to 20 centimeters. What are the properties of the image formed here? It is the inverted image, upside down, and diminished image. Compare the sizes of object and the image. The size of the image is smaller than the size of the object. Hence, it is the diminished image and real image because we got it on the screen. So let us write the properties of the image formed here. Inverted, diminished, real, and image distance is equal to 20 centimeters. Okay. Next, case 4. In this case, I am going to place the object still further closer. Focal length of lens is 15 centimeters. So at this position, I am going to place the object, candle. Okay. Now let us measure the object distance by using the meter scale. Here it is 50 centimeters. So object distance is equal to 15 centimeters. Let us bring the screen from the left side towards the lens slowly until clear image is formed on it. So at this position, I got the clear image on the screen. Okay, so let us measure the image distance. It is 22 centimeters. So image distance is equal to 22 centimeters. So properties, we can see here clearly it is inverted. Okay, diminished, compare the sizes. Image size is smaller than the object size, and real image because we got it on the screen, and image distance is equal to 22 centimeters. Okay. Next, case 5. Here focal length of lens is 15 centimeters only. It is a fixed value. I am repeating every time. So here wooden block is there. On this I am going to place the candle and I will measure the object distance. That means object is placed now at the distance of 40 centimeters from the lens. So here object distance is equal to 40 centimeters. Let us see where its image will be formed on the screen. So here image has been formed. So let us measure the image distance now. It is 24 centimeters. You can see here clearly. Okay. So image distance is equal to 24 centimeters. What are the properties of the image formed in this case? Obviously it is inverted image we got and diminished. Actually the size of the image is gradually increasing. when the object is moving slowly towards the lens and image is moving away from the lens, but its size is gradually increasing. So inverted, diminished, real, and image distance is equal to 24 centimeters. Okay. Now case 6, in this case I am going to place the object, that is candle, at the distance of 30 centimeters. That means exactly at the center of curvature. So here focal length of lens is 15 centimeters, means 15 into 2, 30 centimeters. That is at the center of curvature I have placed the candle. You know, you can imagine where its image will be formed on the other side of the lens. Exactly at the distance of 30 centimeters only its image will be formed. So when the object is placed at the center of curvature, image will be formed at the center of curvature on the other side of the lens. Okay. So let us measure the distance here. Object distance is equal to 30 centimeters. Let us write it. And I am bringing the screen. So here I got the image. Now, very interesting thing. Let us measure the image distance. It is also 30 centimeters. So image distance is equal to 30 centimeters. Now, observe the properties of the image formed here. Just you see the sizes. The size of the object is equal to size of the image. Both are equal in size. Okay? And inverted, real. Inverted, same size as that of object. Real image, because I got it on the screen, and image distance is equal to 30 centimeters. Okay. Next case 7. In this case I am going to place the object, that is candle, at the distance of 20 centimeters. Let us see here. And here is the candle I have placed on the wooden block, and the distance of the object, that is the burning candle, is 20 centimeters. Here, write down here. And let us bring the screen slowly towards the lens until we get the clear image on the screen. So this is the screen I am bringing slowly towards it, and here I got the clear image. So this is the object and its image has been formed on the screen at this position by this convex mirror, double convex lens, not mirror, it is a lens. Okay. Now, so let us measure the image distance. See here, from here to here, 60 centimeters. So the image distance is equal to 60 centimeters. Can you write the properties of the image formed here? Very simply properties, because you can see the image clearly. So it is the magnified image, that is the size of the image is bigger than the size of the object. So inverted, magnified means large in size, and real image, because we obtained this image on the screen, and image distance is equal to 60 centimeters. Okay, just now I have measured the distance. Remember, all the distances should be measured from the lens only. Okay. Next case 8. So here focal length of lens equal to 15 centimeters. Now I am going to place the object very close to the lens. So let us measure its distance. It is 15 centimeters. That is, at the focal point only, I have placed the object in front of the convex lens. So here, object distance is equal to 15 centimeters, that is the object, that is candle, has been placed at the focal point. You know, when the object is placed at the focal point, its image will be formed at infinity. That means we cannot obtain that image on the screen. It is imperceptible, unambiguous. So let us see here whether image forms or not. No. So image has not been formed on the screen. Okay? So that means image might have been formed at infinity, either this side or this side. So it is ambiguous. We do not get the image on the screen when the object is placed at the focal point. I already told you in ray diagrams. So image distance is equal to infinity. Okay? So let us write the properties. Image will not be formed on the screen and it is formed at infinity. It could be formed on the same side, that is on the same side of the object, or on the other side of the object. So it is imperceptible, ambiguous. Now I am going to show you a special case. See here, what is that special case I am going to show you? If the object is placed at less than 15 centimeters from the lens, can we obtain the image on the screen or not? This is the question. That means, if we place the candle between the optic center and the focal point, that is between P and F, if the object is placed, can we obtain the image on the screen or not? Never. We do not get that image on the screen. When the object is placed at less than 15 centimeters from the lens, we cannot obtain the image on the screen, because the virtual image will be formed on the same side of the object. So let us see this one. So see here. Now this one is a special case, case 9. In this case, I am going to place the object at the distance less than 15 centimeters. That is between the optic center P and focal point F. In between, I am going to place the object. So let us check. Focal length of lens equal to 15 centimeters. Now I am going to place the object here. This is the burning candle I have placed on the wooden block. A different block I have taken. Okay. So here let us measure the object distance, that is the distance of the candle, is around 12 centimeters. So this 12 centimeters distance is less than the focal length. Okay. Now object distance is equal to 12 centimeters. Now we have to check whether its image will be formed on the screen or not. So I will bring the screen slowly from left towards the lens. I will bring the screen slowly from left towards the lens till I get the clear image on the screen. So see here, I am moving it. Observe very carefully. Yes. So from here to here, I haven't got the image on the screen. So here no image on the screen. Image has not been formed on the screen when the object is placed at the distance less than the focal length of the lens, less than 15 centimeters. Okay. Now here the convex lens will form a virtual image of this object on the same side, and this virtual image is visible only for the observer here. See here, here is an observer, and this observer can only see this image. We cannot see this image, and with respect to observer only I am talking about, and she only can see this image. We cannot see. For understanding purpose I have shown here, but we cannot see this image actually, and observer can only see this image, and this image is visible only to this observer. Okay, na? So here, when the object is placed between P and F, between the optic center P and the focal point F, its image will be formed on the same side, and let us observe the properties of the image formed. And this image is a virtual image. If you hold a screen at this position, okay, we cannot get the image on the screen. Okay, so it is, this image is visible only to this observer. Okay, now let us write the properties of the image formed here. See here, it is the erect image. Erect means upright image. And magnified image. Let us compare the sizes of object and image here. The size of the image is more than the size of the object. Next, virtual image. Why? Because we cannot obtain this image on the screen. We don't get this image on the screen. That's why it is a virtual image, and it is visible only to this observer if she sees through lens from the left side. Okay, and that one. Now let us calculate the focal length of the given convex lens by using the observed values with the lens formula. So here is the lens formula, 1 by f equal to 1 by v minus 1 by u. So far we have observed, we have measured u and v values in different cases, and those values I am going to substitute in this formula. And while using this formula, we have to follow the sign conventions. So here is the sign convention for convex lens when real image is formed. So see here all the distances, in case of real image I am talking about, so all the distances should be measured from the optic center P only. Okay, if you measure any distance opposite to the direction of the incident ray, we have to take that measurement as negative. And if you measure any distance along the direction of the incident ray, we have to take that distance as positive. So here, this is the object. So OP is the object. So here we have to measure its distance from P. That means we are measuring its distance opposite to the incident ray. So incident ray is from left to right, it is coming like this. So I am measuring the distance from P to O like this. So here U is negative. U is negative. In this formula we have to take U as a negative. And image distance I am measuring from P to I. P to I is the image distance. Here I am measuring along the direction of the incident ray. This is the incident ray. So I am measuring along the direction of the incident ray. That's why V should be taken as positive. And here is the focal point. So focal point means from P to F, it is the focal length, and the focal length for convex lens, it is positive from here to here. I am measuring along the direction of the incident ray. That's why we have to take it as positive. So in this formula, while using this formula for convex lens, when the real image is formed, we should take F as positive, U as a negative, and V as positive. Okay? And here is a sign convention when a virtual image is formed by the convex lens. So when the convex lens forms the virtual image, so it is possible only when the object is placed between the optic center and the focal point. So here, when the object is placed between P and F, its image will be formed on the same side of the object here. So this is the image. So OB is the object and IG is the image. And can you tell what is the sign convention for U? Here PO is the object distance. Here I am measuring from P to O. That means I am measuring to the direction of the opposite direction of the incident ray. That's why U is negative. V is also negative. P to I, it is the V. Image distance, it is also negative. And small f, that is focal length, is positive. Okay, so in this case, U and V both are negative and F is positive. So here is our lens formula, 1 by F equal to 1 by V minus 1 by U. In this formula, F is the focal length and V is the image distance and U is the object distance. So let us simplify this formula for convex lens when it forms a real image. Even for virtual image also we get the same formula, same simplification we will get. So according to sign convention, convex lens real image. So here F is positive. Just now I have told you U is negative and V is positive. Let us substitute in this. Hence 1 by F equal to 1 by V plus 1 by U. Because U negative means negative becomes positive, or if you simplify it, F equal to UV by U plus V. So to find the focal length of the given lens, we have to use this formula. UV by U plus V, that is the product by the sum. U means object distance, V means image distance. Okay? And the same formula you get even for virtual image formed by the convex lens. Okay? So here is the lens formula. Let us simplify this formula for virtual image formed by the convex lens. 1 by F equal to 1 by V minus 1 by U. Just now I have told you, in case of virtual image, U and V both are negative and F is always positive for convex lens. So according to sign convention, convex lens virtual image. Okay, see here, F is positive, U is negative and F is also negative. If you substitute these signs in the lens formula, it becomes as 1 by F equal to minus 1 by V plus 1 by U, or F equal to VU by V minus U. Okay? There in previous case for real image, I got F as VU by V plus U. Here F equal to VU by v minus u. However, in this case also f is positive. In the previous case also f is positive. Why? Because in this case, in case of virtual image formed by the convex lens, v is always greater than u. So when v is greater than u, v minus u is positive. Okay, so f is positive. Now I have tabulated all our observations. We have noted down. See here, serial number, that is in the first case when the object was placed at infinity, image was formed at the distance of 15 centimeters in this case, and focal length is 15 centimeters. So when the object is placed at the distance of 70 centimeters, image distance we got as 19 centimeters. Let us substitute these values in this formula. F equal to uv by u plus v. 70 into 19 by 70 plus 19, we get almost 14.94 centimeters. And when the object was placed at 60 centimeters, we got the image distance 20 centimeters. And after substituting these values in this formula, we got 15 centimeters. Similarly, 50, 22, here I got f value as 15.27 centimeters. And 40, 24, substituting these values in this formula, that is the lens formula. So 40 into 24 by 40 plus 24 is equal to 15 centimeters. Okay. So this is the first case, second case, third case, fourth case, fifth case. And see here, serial number 6. Object distance is equal to 30 centimeters and image was also formed at the distance of 30 centimeters. And in this case, f, if you substitute these values in this formula, we get f as 15 centimeters. And when the object was placed at 20 centimeters, image was formed at the distance of 60 centimeters. So here f is also 15. And when the object was placed at the focal point, that is at the distance of focal length 15 centimeters, and image distance, image could not be formed on the screen. So image distance, we take it as infinity. And in the last case, when the object was placed at the distance of 12 centimeters, in this case, we didn't get the image on the screen because it was the virtual image. Virtual image was formed on the, virtual image was formed. That's why we didn't get the image on the screen. Okay. So these are the focal lengths. In each case, I have calculated. So in order to find the focal length, we have to take the average of all these values. See here, we can calculate the focal length of the lens by taking the average of all the values in column 4 of the above table. See here, average focal length is equal to, in the first case we got 14.94 plus 15 plus, so we got in 6 cases, we have calculated focal length in 6 different cases, and 1, 2, 3, 4, 5, 6 by here, average focal length equal to sum of these quantities divided by 6. So here we get the average focal length as 90.21 by 6. It is equal to 15.04 centimeters. Though here the observed values, that is the measured object and image distances, are correct. Isn't it? Because we have taken the convex length of known focal length of 15 centimeters, and the calculated focal length is tallied with the focal length we have taken as 15 centimeters. Okay. While doing this lab activity, there are some precautions. So here I am writing all those precautions. So place the convex lens on the V stand vertically. V stand and the screen should be on the same line, and measure the image distance only when the clear image is formed on the screen, and while looking the image on the screen, the minimum distance between eye and image should be 25 centimeters. So
చూశారు కదా ఫ్రెండ్స్ యానిమేషన్ వీడియో. మరి కాన్వెక్స్ లెన్స్కి సంబంధించిన యూవీ మెథడు, 1/U 1/V మెథడు మరియు కాంజుగేటివ్ ఫోకై మెథడు సంబంధించిన వీడియోస్ మీరు చూడడం జరిగింది. ఈ విధంగా మనము ఎక్స్పెరిమెంట్ అనేటువంటిది కంప్లీట్ చేయడం జరుగుతుంది. ఓకేనా?